So welcome back to Transcendent. In today's tutorial, we are going to solve these questions for math. That is the paper for 2024, and this paper has got a lot of questions. So there is question 1, which we're going to talk about how to solve the simultaneous equation and everything. So if you want to access all the solutions for this paper, the solutions are there, and some of them we are still discussing, and you'll be able to see the videos. So let me just show you some of the videos that we have. I have uploaded a video that is, if you go here on YouTube, I think you'll be able to see one video which is saying math 2024 exam paper, that is 46 minutes. So if you want to access this video, just go on website, then go the part for past papers, then you'll see where it's saying new papers. So just click there, you'll be able to see the solutions and the recorded classes for the revisions that we are doing. Okay, so specifically for this video, we are going to talk about rational functions. So let's get into it. Now let's talk about how to sketch rational functions. A rational function is going to have either vertical asymptote, horizontal asymptote, and slant asymptote. Slant asymptote is also known as oblique asymptote. Okay, but in more like, I think 80% cases, especially for first years, is in rare situation where you are going to find a question which has got a slant asymptote. Yes, they can give you, but it's in rare situation. Now let's do this. We have x squared. I'll write this question here. The question goes like this: x squared g of x is equal to x squared plus 1. But I have forgotten what is supposed to be here, down here. X squared plus x minus 2. X squared minus x minus 2. Okay. Let's first talk about how to find the vertical asymptote. There will be no exam without this question. Whether you like it or not, this question will always be there. And this question will always carry a lot of marks. Have you seen here is 8 marks. Now for you to get 8 marks, I want you to follow me step by step. Okay? I want you guys to follow me step by step. The first thing is you need to find the vertical, because the question, if you read the question, determine the intercept. We need to find the intercept, the vertical asymptote and horizontal asymptote, and also slant asymptote if at all we have, and hence sketch the graph. 8 marks. So to find the vertical asymptote, get what is on the denominator only. X minus x minus 2 is equal to 0. Get what is in the on the denominator only, equate them equal to 0. Does that make sense? This is plus, eh? This is plus. Then solve for x. This is a quadratic one. The product is -2. The sum is positive 1. The factors should be negative or positive 2 and -1, because positive 2 times -1 is -2. Positive 2 minus 1 is positive 1. So it's x plus 2 and x minus 1 is equal to 0. X is equal to -2 and x is equal to 1. Who has got a problem on how to find the vertical and the vertical asymptote? So now the vertical asymptote is that x is equal to -2 and x is equal to 1. 10. Who has got a problem there? So you are not responding. Don't get confused here. What I have done here is what you know. Here. It's what you know. What you know, you guys, is simple and straightforward. This is what you know. You know that when we find the factors, you replace this. Serious? So I start afresh. I start afresh or I continue from here. Yeah, I'm moving at the speed of light. Can you imagine it? Okay. So I'm moving at times 2. The speed at times 2. But now, let me put at zero 0.5. So when you want to find the vertical asymptote, you look at the function that you have been given, that is the rational function. By the way, a rational function is a function that is in the form of f of x is equal to 1 over ax plus b. Or let me say a, then bx plus c. As long as on the denominator x appears, then that one we call it a rational function. Okay? Now what we have here, we have a rational function. A rational function that we have is x squared plus 1 divided by x squared plus x minus 2. The question is we need to find the vertical asymptote, horizontal asymptote, and the slant asymptote, if at all we have slant. But I'm going to explain if we're going to have or not. The vertical asymptote is found by getting the denominator equal to 0 and solve for x. If you look at this question, it is x squared plus x minus 2. It's a quadratic equation. Product is negative 2. Sum is positive 1. What are the factors? The factors, what we're talking about is two numbers. When you multiply them, they give you negative 2. When you add them, they give you positive 1. I have found positive 1, positive 2, and negative 1. After finding these, the next thing that you're supposed to do is you replace now this x with the factors. So x squared plus 2x minus x minus 2 is equal to 0. Factor out x, the first one. You remain with x. Here, if I remove x, it will be plus 2. Then I'll factor out 1 there. It will be x plus 2 is equal to 0. Now that these are the same, we just pick 1. I think this part you know it. So x minus 1, put them in brackets. Then x plus 2, put them in brackets, is equal to 0. I reached at this point, the time I was telling you to say, you just get the factors when this is positive 1. When x squared has got positive 1, you just get the factors and put them in brackets. That's what I did. But don't do that. So then, you can shift now, it will be x plus 1 is x minus 1 is equal to 0 and x plus 2 is equal to 0. So x is equal to 1 and x is equal to negative 2. What about now? Still the speed is too much. I want someone to respond. I'm still moving at the speed of light. Now I'm moving at the speed of Toto Isra. Okay. So what I'm going to do, I'm going to create space here and say these are my vertical asymptote. So you write, guys, like the way I've written here, vertical asymptote. You underline it, then you solve. So you need to show them. You solve. So here we have solved and we have found that x is equal to 1 and x is equal to negative 2. Those are my vertical asymptote. Let's now go ahead and look at the horizontal asymptote. So horizontal asymptote, you write the full word horizontal asymptote. So here I'm going to write AH, horizontal asymptote. Okay, so horizontal asymptote, there are only two things that I want you to understand. There is what we call the function is bottom heavy. For example, if you have f of x is equal to maybe 1 divided by x minus 1, this function is bottom heavy. What do we mean when we say the function is bottom heavy? The degree of x on the denominator is higher than the degree of x on the numerator. So you can clearly see that down there I've got x, then on top I don't have x. This function is bottom heavy. If the function is bottom heavy, the horizontal asymptote is y is equal to 0. If the function is bottom heavy simply means the degree of x on the denominator is higher than the degree of x on top. Therefore, in that case, the horizontal asymptote is 0. You understand? Now, another thing that I want you to understand is that bottom heavy, what I mean here is this. Another scenario is maybe you have got x minus 1, then you have got x squared minus x plus 2. This function is still bottom heavy because here I've got x to the power 2, here I only have x to the power 1. So this one is bottom heavy. Horizontal asymptote here is 0. Another scenario is when the degree of x on top is the same as the degree of x on the denominator. In that case, we just divide the coefficient of those two guys which have got the same powers. Does that make sense? So in this case, the horizontal asymptote, I'm going to get the coefficient here is 1. I divide it by the coefficient here again is 1. So the horizontal asymptote is y is equal to 1. There are only two cases. A situation where you have got a function where the numerator has got the highest power than the denominator. At this point, you have got no horizontal asymptote. This is the situation where you are going to have a slant asymptote. Slant asymptote is also known as oblique asymptote. So a situation where the numerator has got the highest power of x than the denominator, then at that point you have got the slant asymptote. That's why the question here is saying, where there is slant, they have said determine the intercept, vertical, horizontal, and the slant asymptote. In the brackets they have said if n. Come on guys. So do we have slant asymptote in this case? This is the question. We don't have, because on top we have got x to the power 2, down we also have x to the power 2. So we have got the horizontal asymptote. So in that case we don't have slant asymptote. Now you have found the asymptote. You need to find the intercept. That's why this question is big. So the horizontal asymptote is at y is equal to 1. You need now to find the asymptote. How do we find asymptote? Come on. Intercept. How do we find the intercept? Let's start with the x-intercept. Okay? X-intercept. To find the x-intercept, equate y equal to 0. Come on, guys. So this is the function. Y is equal to x squared plus 1 divided by x squared plus x minus 2. Where there is y, put 0. So x squared plus 1, you divide it by x squared plus x minus 2. Divide here 0 with 1, then cross multiply. So x squared plus 1 times 1, it is x squared plus 1. Then this times 0, that is going to be 0. Shift 1 to go to the other side. X squared is equal to negative 1. Can you square a number and get negative 1? Hmm? So you can't square a number and get -1. In this case, then we don't have x-intercept. So we have got no x-intercept. Okay? We don't have x-intercept. You solve this, you show it. Okay? Next, we need to find now the y-intercept. We have shown that there are no x-intercept. Let's now go ahead and find the y-intercept. To find the y-intercept, equate x to be equal to 0. The same equation, x squared plus 1, x squared plus x minus 2. Now replace x with 0. 0 squared plus 1, 0 squared plus 0 minus 2. So y will be equal to 1 divided by -2, that is -half. So when the y-intercept that we have is when x is 0, y is -1/2. This is the y-intercept. So we have no x-intercept. From what I have, you can even clearly see that we have spent time just to find the asymptote and the intercept. This part alone, it is about, I think, 5 marks. You're finding the asymptote, the intercept, because you are finding both the vertical and horizontal. If at all you are going to have the slant line, you are going to do that as well. Okay? Next, you need to find the intercept. To find the x-intercept, like I've said, equate y equal to 0. So for x. To find the y-intercept, equate x equal to 0. To find the x-intercept, equate y to be 0. Then solve for x. To find the y-intercept, equate x equal to 0. Solve for y. That's all. After finding the intercept and the asymptote, you can go ahead and now sketch the graph. So there we go. Vertical asymptote cuts the x-axis. So when x is equal to 1, it will cut there. You put a dotted line at x is equal to 1. At x is equal to -2, you also put a dotted line cutting that point. Y is equal to 1. When y is 1, again, you need to cut like that. After cutting these asymptote, now after putting the asymptote, you need now to focus on the intercept. The only intercept that we have is 0, -1. So -1 can be found here. -1 is approximately -0.5, which is closer to 0. So it is here, -1/5. So 0, -1/5 is the same point here. There are no x-intercept, meaning that the graph can never cross this line. If you only have one point, get me right there, you only have one point, and that point, it is the x-intercept, sorry, the y-intercept, meaning that the graph will always goes like this. Because I've got a point here, it can't go like this because we don't want it to cross the what? The x line. So it will start from this line, running away from the asymptote, touching there, then it comes there, near, then you put the arrows because we don't know where it is ending. This part here, it has curved. It has to be reflected the other side. So it will be reflected here. This part here, this curve is going to be reflected to the opposite side, which is this side. So this is the graph of this function. From what we have done here, we have gotten our 8 marks. It's complicated. complicated. So this is what you are supposed to know when it comes for graphing the rational functions. So like I said, if you want to access all the solutions for this paper, just log in, go on our website. If you are registered, if you are not yet registered, go on website and then type Transcended Institute. So when you type Transcended Institute, this is what we're going to see. So you go on math, then the part for past papers. If you click on past papers, you'll be able to see the part that is saying math past papers solution 2025. So if you click there, you'll be able to see the full video for these past papers. Okay, so register with us, don't hesitate, let's revise together. So that is it for this video.